Hello, everyone, and welcome to the 5th session of the Massive Open Online course for the University of Nicosia's Master's Degree in Digital Currencies. This is the 8th time we're running the MOOC, and I'm very glad to see massive participation this time. So stand by on the forums, ask good questions. Let's start the conversation. Today, we're going to be discussing a lot of different topics, especially around mining, forking, and various blockchain consensus things. Great. Let's start with Lydia asks, is there some sort of test platform where beginners could get a feel for the Bitcoin core program and how it implements the Bitcoin protocol without having to download the program and the whole blockchain? Lydia, yes and no. There is a test platform, and it's called testnet. And testnet is a completely parallel blockchain of Bitcoin on which, from a new Genesis block, and which uses a Bitcoin currency called Bitcoin testnet coins. And Bitcoin testnet coins have no value. And the only purpose of running Bitcoin testnet is so that you can test applications, transactions, etc., without the fear of losing money. On Bitcoin testnet, you can find various faucets that will give you test coins to play with. And it has real mining and real consensus rules. It operates in lockstep with the latest developments on the Bitcoin blockchain, more or less. Ovice asks, which one is better for managing the full client wallet? Graphical user interface or command line interface? Well, that depends very much on what your level of expertise and comfort is. For most users, quite honestly, a graphical user interface is better. And unless you're doing development or really want to dive into Bitcoin, it's probably easier to install a mobile wallet on your smartphone. But if you're running Bitcoin Core, I would encourage you to get familiar with both the graphical user interface and the command line interface, because a lot of your development work is going to happen on the command line. Dominic asks, what does block index refer to if block height is used to calculate the block number from the Genesis block? Perhaps I'm misunderstanding the terminology here, and George can jump in and tell me if I missed something from the slides. But block index and block height pretty much refer to the same thing. Block height is the number of blocks that have elapsed since the Genesis block, which is block 0. And so at this moment, we're some 400,000 blocks. And that one of the things to notice is that the block height is not actually stored inside the block. So you don't see the block height in the block, or at least you didn't see the block. Sorry, let me rephrase that. The block height itself wasn't part of the block data structure until BIP34. And BIP34 changed that in, I want to say 2015, I might be wrong. And since then, the block height is incorporated as a field in the Coinbase, which effectively means that each miner commits to a specific block height in the Coinbase. If a Bitcoin wallet can create multiple addresses for each transaction with a new public and private key for each of these addresses, how does the mnemonic phrase know how to restore them? Great question from Stephen. So the mnemonic phrase, or often called the seed, although that's not exactly right. The seed is a random number, and the mnemonic phrase is that random number expressed as a series of words, usually in English, but could be other languages with a checksum. So the mnemonic phrase is actually the basis for all of the private keys generated by your wallet, meaning that the mnemonic phrase is used to calculate a root public key, as it's known, and a root private key as part of a hierarchical deterministic wallet, or HD wallet. What this type of wallet does is it allows you to generate a private key from the master and then generate another private key and another private key and another private key. All of these are called children, and they are derived in a tree-like structure. But for simplicity purposes, let's say that a mnemonic phrase allows you to calculate a master private key from which all private keys are derived in sequence. So how does the wallet know how to restore them? If you give it a mnemonic phrase, what it's going to do is it's going to first generate the first child 0 of the master private key from that mnemonic phrase. It's then going to check the blockchain and see, has that been used? Has there ever been a transaction using that address, that Bitcoin address? So it will check, and if there has been, that means this wallet is in use. So then it's going to look at the second, and then the third, and the fourth private key. It's going to generate the second, third, and fourth address. It's going to look on the blockchain and say, have these been used? And it will keep scanning for all of these private keys. Once it finds 20 sequential Bitcoin addresses that have not been used ever, that number 20 is called the gap limit. Once it finds a gap of 20 unused addresses, it assumes that you have not used any more addresses from that wallet. And it says, OK, it looks like we have found all of the addresses in use, which is why your wallet takes care not to leave a gap of more than a few addresses unused. So it will scan, it will find all of the transactions corresponding to all of those addresses, and it has the private key so it can spend any money that's in there. So that's how the wallet uses a mnemonic phrase to restore your funds, because it generated all of the private keys in sequence from that mnemonic phrase. And if you enter the mnemonic phrase, it can generate them again, scan the blockchain, and find out if they've been used. A clarification, Steve asks, the private keys are never stored or transmitted to the blockchain, and the public key can't reveal the private key. So where is this information made available for restoration via the mnemonic phrase? So the mnemonic phrase is used to generate private keys. Those private keys are used to generate the public keys. Those public keys are double hashed to produce a Bitcoin address. So if you have the mnemonic phrase, you can generate all the private keys. Once you have the private keys, you can generate all the public keys that correspond to them. And from the public keys, you can generate all of the addresses. So at the end of it, once you put a mnemonic phrase into a wallet, it will generate a whole bunch of private keys, the corresponding public key for every one of them, and the corresponding address, and then it will look on the blockchain to find if those have been used. So the mnemonic phrase is basically the source of all of the private keys. And the next question comes from Lazar. He says, what is the incentive of running a full node since miners are getting the rewards? Lazar, the reason to run a fully validating node is so that you have the ability to independently and authoritatively determine whether a payment has been made, whether a transaction has been made and is valid. So the reason you would run a full node is because you want to run a wallet or a service that operates a wallet, such as a merchant service or an e-commerce service or something like that, or just your private wallet. And you want to know whether a transaction has happened. Now, you could ask a block explorer. You could type in the Bitcoin address and go to blockchain.info or BlockCypher or one of those block explorers, and you could ask it. But in that case, what you're doing is you're trusting a third party to give you a correct answer, and maybe that third party has been compromised. Maybe there's an error, maybe whatever. You can't depend on that if you're really looking at Bitcoin as a fully decentralized protocol where you don't trust third parties. So as a result, that will give you can get that kind of security from running a full node, and that way you're not trusting any third party. Paul asks, would there be any way to launch an attack on Bitcoin if you somehow manage to feed an incorrect time to the nodes? Where do nodes and clients refer to for time? Paul, that's a great question. There are two broad measures of time that are used within Bitcoin. There's consensus time, and then there's not consensus time. So all the nodes that are connected to the Bitcoin network should have their own sense of time. And usually the way to establish what time it is through the use of a protocol called NTP, which stands for Network Time Protocol. This is kind of outside the scope of this, but you see it's on your desktop where it says it will connect to a server to get the correct time. Cell phones do it via their cell towers or GPS functions. Laptops do it through a TCP connection or UDP connection to a time server that provides them a timestamp. So generally speaking, servers, desktops, laptops, any operating system on the internet can fairly easily synchronize with a global network of time servers that gives it a fairly accurate vision of what the time is. Now, of course, if you change the time on a node, you're going to have some discrepancies. But there's a more important measure of time, which is consensus time. And consensus time is called MTP, which stands for median time passed. Median time passed was introduced last year as a soft fork. It allows you to have a measure of time that is based on the median of the last 11 blocks. Timestamps. What that means is that you take the median time of the last 11 blocks, which is about an hour behind wall clock time, and that counts as consensus time. That is the time based on which things like lock time, check lock time verify, check sequence verify, and things like that operate. And there are rules as to whether your node will accept a block that deviates from the median time passed and from generally the expectation of time you have. So miners can shift the time they put in a block by a bit, but not a lot. They don't have much wiggle room. If they move it too much, then that block will be considered invalid and will be rejected by everyone on the network. And because median time passed calculates block time over the last 11 blocks, the assumption is that those 11 blocks were mined by different miners because of competition among miners. And therefore, a miner could skew the time in one block, but they can't effectively skew the time in several blocks in order to do a kind of fee sniping where they include a transaction that has a lock time early in order to earn the fees from that, even though it's not supposed to be included yet. So median time passed provides that protection. Albert asks, is it dangerous if one day a private key can be inferred from a public key? Yes and no. It is dangerous in that if you are reusing addresses and you've published your public key on the blockchain as a result by making transactions using that, and there is still a balance left, then presumably someone who had, let's say, a quantum computer that could reverse the elliptic curve digital signature algorithm or reverse elliptic curve multiplication and derive from either the signature or the public key the private key, then you have a problem. And that's a pretty big problem. And they will be able to spend your money. So the way we defend against that is by not reusing addresses. And by not reusing addresses, if you only use an address once, that means that whenever the public key is presented to the network in a spending transaction, that spending transaction spends everything, and change is sent to a different address for which the public key is not yet published. And as a result, if someone can get your private key, at that point, it's useless because there's no money behind that address. So there's a logic to not reusing addresses that also protects against potential future compromises of the elliptic curve algorithm. Now, keep in mind, the elliptic curve algorithm will eventually be too weak to support the funds that are stored on Bitcoin. At that point, people will have to modify their software and use a different elliptic curve or use a different cryptographic primitive for digital signatures. And at that point, everybody will have to upgrade their cryptography to choose something that's stronger. That's a natural thing that happens in security. Cryptography isn't forever. And so at that point, if you haven't reused addresses, you're perfectly safe. But one other thing that will happen that's interesting is that any addresses that have been reused for which the keys have been lost will get drained. All right. Now, the next bunch of questions we have are about forks. But before I go to those, let me just quickly look at some of the follow-up questions that popped up in my chat. Here we go. So we've got a couple of questions following up on the mnemonic phrase. Morgan asks, is a mnemonic key interchangeable across wallets? In other words, can you take one mnemonic key and use it on another wallet app? To some extent, yes. There are two components to how a mnemonic phrase works. The first one is the standard for the mnemonic phrase itself. And there are two dominant standards in this industry right now. One is called BIP39, which was introduced by the Trezor and provides for a dictionary of 2,048 English words with certain key characteristics that make up this mnemonic phrase. And it has a fixed mechanism for deriving keys in a very predictable way that can be reproduced. BIP39 mnemonic phrases are interchangeable, meaning that you can take a BIP39 mnemonic phrase from one wallet, put it in another wallet that accepts BIP39 mnemonic phrases, and it will generate the same master private key in order to build up your wallet. Shengwing asks, if you broke your hard wallet, such as Ledger, how could you use a web client or other clients to recover your data? Again, this goes back to the same question. If you have your mnemonic phrase stored somewhere safely and you break your hardware wallet, or you break your software wallet that uses that mnemonic phrase, you can take that mnemonic phrase and you can restore it either on another hardware wallet or on a software wallet. You can even import it into a web wallet. Of course, some of these solutions are less secure than others, so you should be careful about what you do. But you can, theoretically, take the same BIP39 phrase and use it. Now, I mentioned there's another standard here, and that's the one used by the Electrum wallet. And the Electrum wallet has a different approach to using mnemonic phrases, which was actually developed before BIP39. And the Electrum developers don't consider BIP39 to be secure because of the way it's implemented. So there's a bit of a disagreement in the industry, but you cannot take an Electrum seed and import it into a Trezor, and you can't take a Trezor seed and import it into Electrum. And you can't take a BIP39 seed and import it everywhere. You can only import it in wallets that accept a BIP39 seed. But nowadays, dozens and dozens of wallets accept a BIP39 mnemonic phrase. And as a result, you'll find that it's fairly efficient to move from one wallet to another. There's one other consideration, though, that you must think about. Once a wallet has a master private key, it has a choice as to how it's going to derive private keys from that. And different wallets use different structures, and these structures are called paths. These paths are part of the BIP32, BIP43, and BIP44 standards. And these paths are used to have a specific derivation scheme that allows a wallet to discover the addresses that you're using. And the reason for that is that the tree of potential addresses is quite big. And as a result, a wallet can't just go stumbling around in the dark trying to find which addresses you use. It has to have a specific pattern. The most common pattern is BIP44. BIP44 is a multi-account, multi-currency derivation scheme that allows you to find the Bitcoin, Bitcoin testnet, Ethereum, Dash, and other currencies that are stored underneath the mnemonic phrase's root key, and derives the correct addresses for each currency and sub-accounts and all of those things. You may have seen this in a notation that looks like M/44/0/0/. That's a path defined in BIP32. using a special purpose defined in BIP 43, and that special purpose is a multi-currency, multi-account wallet defined in BIP 44. Now, here's the problem. Trezor uses that, a whole bunch of wallets use that, but some wallets use a different derivation scheme. They don't use 44. Multi-signature wallets use 45 or 48. The Ledger uses a different derivation scheme than the Trezor. So you may have to tell your wallet which path to look on in order to find your private keys. So they're not quite interchangeable, but suffice it to say, if you have your mnemonic phrase and you know what device was using it in the past, you can recover it in hardware, software, or writing a recovery script, or using the services of a recovery company for any currency that was stored there. And it can be done. It just might take a little more work than simply typing it into a new wallet. Giovanni asks, I'm running a full node and using getTransactionTXID. The console replies with invalid or non-wallet transaction ID code -5. What is wrong, since by blockchain info, I can get the transaction details? So Giovanni, what's happening there is that your installation of your full node is not fully indexed. And what that means is that your full node has not created a full index, which is a database index, of all of the transactions that exist in the blockchain. They're there, but it doesn't have an index to search for them. The index actually adds tens of gigabytes to your overall blockchain size, but it then allows you to look up any transaction. Normally, a full node, if you haven't set transaction indexing, will only return transactions that are related to keys found in the wallet. So that's why it's saying invalid or non-wallet transaction ID. Basically, it's a non-wallet transaction ID. It's not a transaction that happens with one of the keys in your wallet. If you wanted to have an index of all of the transaction, you have to pass a parameter to Bitcoin Core called TX index. And you have to set that TX index to 1. Once you do that, it will index everything. By the way, that's going to take several days to complete. It's a fairly time-consuming process, and it will use up a lot of disk space. All right, how are we doing so far? Any more questions on the live chat, or should we go into the beautiful topic of forks? Great, forks it is. Let's see. All right. So I'm going to preface this by saying that I will answer all of the technical questions about forks, but I won't answer questions about what the price is going to do, why people are doing X, why people are not doing Y, the motivations, incentives, and drama of particular forks. We'll keep this technical. Donald asks, with SegWit2x coming soon in November, why does the Bitcoin Gold team refuse to implement replay attack prevention? And if they decide not to prevent replay attacks, what can we do to prevent losing our Bitcoins? Okay, so Donald, a few clarifications. SegWit2x and Bitcoin Gold are two different forks. Bitcoin Gold, in fact, is one that was proposed recently that is a fork from Bitcoin that changes the proof of work algorithm in order to make it CPU and GPU hard and memory hard rather than ASIC compatible. So it's basically trying to change the proof of work to go back to the good old days when you could mine on a CPU or GPU rather than using ASICs. SegWit2x is the doubling of the base block size, which actually increases the block weight to 8 megabytes, that is proposed for November as the second phase of the New York agreement. Those are two different forks. As far as I know, Bitcoin Gold and SegWit2x are not yet implementing replay attack, or maybe they are. SegWit2x has merged a pull request to do replay attack by blacklisting a specific P2SH address. And what that means is that if you include a payment to that P2SH address, that transaction cannot be included in the SegWit2x branch because that specific address is invalid. So basically what that means is that you bribe the SegWit2x people to not include your transaction by paying them even dust amounts on this. Now, they say they're going to release the private keys that will allow anyone to spend from this P2SH address, which then creates two possible replay attack preventions. One is to send money to the 3x address, or the P2SH address. And the other one is to spend from that. Both of those transactions will not be valid on the 2x branch. So that's the gist of what's happening with replay attacks. But I think it's important first to explain, what do we mean by a replay attack, and why is it critical? If you have a fork and there is no functional difference in the transactions or addresses between one fork or another, as is the case with SegWit2x and Bitcoin Gold, they change rules in consensus that regard the block size or the mining algorithm, but they don't change anything in how a transaction looks. What that means is that if you have a transaction that you do on the original Bitcoin chain, and that transaction is also valid on the other chain, for example, the SegWit2x chain, and if you make a transaction, let's say to pay a merchant in original Bitcoin, that transaction can then be taken by anyone, copied over, and broadcast on the 2x chain, which will result in the merchant getting paid also on the 2x chain. So you bought a pizza for 1 Bitcoin using old Bitcoin, and the merchant ends up getting one transaction for 1 Bitcoin on the old chain and one transaction for 1 Bitcoin 2x, let's call it, on the 2x chain. And maybe that's not what you wanted to do. One of the problems is that this will also occur with exchanges. Let's say you want to sell your Bitcoin to buy 2x or vice versa. If you send the money to an exchange, the exchange is going to receive 2 transactions, one on each chain, because it's the same transaction, and it will be replayed. And then you will have transmitted both old Bitcoin and 2x Bitcoin to that exchange. And perhaps you didn't want to sell one or the other. So the problem is it causes confusion because you never know which chain you're doing a transaction on. There are a number of ways to implement various kludgy forms of replay protection. But the best way to implement replay protection is one that involves a change to the new chain. Let me explain why. Replay protection itself means that a transaction that is valid on one chain is not valid on the other. And it doesn't matter which way you do it, but it's important that you have a difference between the two formats of the transaction. Now, since in this particular example, 2x is forking in November, 2x is changing the rules. While changing those rules, it has an opportunity to change the transaction format sufficiently that it is no longer valid on Bitcoin. For traditional Bitcoin, or the original chain, to make that change, it would have to also do a hard fork. So that's why Core can't implement replay protection. It has to be the chain that's forking that implements replay protection. And then there are good and bad ways of doing replay protection. So replay protection to a blacklist address, such as has been done in 2x, is not ideal. There are a number of opportunities for mischief. Having a blacklisted address in itself means that you can execute certain attacks on the 2x chain, which end up costing people on the 2x chain money because they didn't anticipate that this was a blacklist address. One example is to use that address in the refund portion of a payment channel, making that refund transaction invalid. Someone who wasn't paying attention would have noticed that, and they would basically lose the money in the payment channel. The same thing can be done with atomic swaps, with various types of smart contracts, etc. A better way of doing this is using the op return. You see, part of the problem is you don't want the replay protection mechanism to bloat the blockchain, or worse, bloat the UTXO set. And you don't want to do that on either chain. So by introducing another output that pays a blacklisted address, that not only bloats the blockchain, both blockchains, but it also bloats the UTXO set because you have to keep track of those spendable outputs. Op return, which is a script operand that you can use, can be used in such a way that it doesn't bloat the UTXO set because it's a non-spendable output. And you could have an op return function that specifically is excluded from the 2x chain, and that gives you replay protection for a very low cost, both in data size, bandwidth, blockchain bloat, and fees. That's the mechanism that Bcash, or Bitcoin Cash, sorry, implemented. And Bitcoin Cash implemented an op return-based replay protection. Let's go through some more questions on forks. Let's see what's happening in the forums. Have I lost you yet? Did you understand any of that? Speak up or not. Let me know if you need some follow-up explanation on replay protection. And let's go to the next set of questions. Edwin asks, with each hard fork and the creation of a new cryptocurrency, does this influence the reputation of Bitcoin in a negative way? If these hard forks continue, will there be more divergence in the Bitcoin developer community and less inclination for third-party support, leading to less use of Bitcoin as a currency? I can speculate on the answers to both of those questions, Edwin, because they have more to do with economics, politics, and reputation than they do with the technology. Hard forks are not a particularly good way to resolve consensus disagreements. I think they're kind of the ultimate tool when all other techniques have failed, and there's no way to achieve consensus between different opinions on how Bitcoin should evolve. But on the other hand, I look at hard forks no differently than I look at the emergence of new alternative blockchains or ICO tokens or things like that. You know, once there was one thing and it was Bitcoin, and now there are thousands of things, and these thousands of things have different uses and different functions and different recipes, from ICO tokens to the various alt chains or alternative blockchains to the various other tokens and to the various Bitcoin forks. So, you know, the day before Bitcoin Cash, we had, you know, I don't know, 1,000 different blockchains, and now we have 1,001. The only difference is that Bitcoin Cash essentially has a gift for every existing holder of Bitcoin by leveraging the history and giving everybody a free amount of Bitcoin Cash on launch. So Bitcoin forks are slightly different from alternative blockchains in that anyone who already has Bitcoin gets a special bonus. That's the same thing that happened with clams back in, I don't know, 2014. It doesn't really change anything. I think for me, the idea that the reputation of Bitcoin is that is only secured by a maximalist single coin dominates everything zero-sum game mentality is really representative of the way we've looked at traditional currencies. So, you know, if there's competition against the US dollar, does that reduce the US dollar's influence in the world? Well, yes, in a zero-sum global geopolitical game, yes. But Bitcoin launched the era of thousands and thousands and thousands of digital currencies, and there will be tens of thousands, and then there will be hundreds of thousands of digital currencies. And we just have to get over the idea that there will be one, or that dominance matters, or that this marketplace is a closed system where one gains only at the expense of the other. David asks, can SegWit have more transaction given that it calculates block weight and not size? Why are people pushing for SegWit 2x before the generalization of SegWit transactions and before we have reached the limits of this new feature? Yes, SegWit allows you to have blocks that are approximately 1.5 to 2 times in size, depending on how broadly utilized SegWit is. And it's already leading to more transactions on larger blocks than 1 megabyte. Because the block weight allows you to expand that space. Why are people pushing for SegWit 2x before the generalization of SegWit transactions? I think primarily because this is no longer a pure technical debate. This is about who gets to make the decisions, who has power over the system, how is that power expressed, who represents best the interests of the users. And quite honestly, at this point, that question is not going to get answered by debate. It's only going to get answered by market forces. I expect the SegWit2x hard fork will happen, and then the market will tell us whether it was necessary or not by showing us how many people are interested in using it. And part of that is going to be seeing where the power lies in this ecosystem. Does it lie with miners? Do they get to decide what the rules are? Or does it lie with users? Does it lie with nodes? Does it lie with economic activity? And some of the big companies that are in the space that have custodial accounts, do they represent the economic activity of their users, or do they serve their users? And is there a difference between the two? All of these are interesting political questions, and we're going to see the market answer them over the next year or so. Christoph asks, is the upcoming activation of segregated witness considered a hard fork? I think there's a bit of a misunderstanding. Segregated witness was activated a couple months ago, or a month ago, and a month and 10 days ago. And oh dear, I'm really having trouble with this. 2 months and 10 days ago, thank you, on August 1st, SegWit was, the voting started. And segregated witness is now active on the blockchain mainnet. It was done by soft fork. There is an upcoming hard fork. That's SegWit2x. It's not the SegWit part. It's the 2x part. The 2x part is the second leg of the New York agreement that implements a increase to 2 megabytes of the base block size, which together with SegWit will take the maximum weight of a block to 8 megabytes. Second question from Christoph is the activation of Bitcoin Gold considered a mere airdrop? I'm not going to really answer that because that's a judgment, subjective question. I'll explain what an airdrop is. An airdrop is the idea that existing holders of Bitcoin get this additional currency called Bitcoin Gold, or segregated witness 2x, or Bitcoin Cash, or whatever the other forks are. And it's called an airdrop because it's almost as if someone dropped money from the air and you suddenly have access to it. I don't know if Bitcoin Gold is just that or more. I don't think it's just an airdrop. It clearly represents a significant change in the consensus rules because it's changing the proof of work algorithm. I don't know if anybody's going to be interested in that. As for the upcoming SegWit2x hard fork, asks Stephen, where should we anticipate market? Sorry, that was a question by Christoph. As for the upcoming SegWit2x hard fork, where should we anticipate market value to stick? That's a good question. As of today, we are getting some indications of market value. Yesterday, the exchange Bitfinex launched essentially a futures contract that allows you to trade today the post-fork versions of SegWit2x and traditional Bitcoin. And sorry for the cumbersome terminology here. I'm trying not to use words in a way that takes sides, which is why I'm saying traditional Bitcoin. I'm not deciding which one is Bitcoin. I don't think I get to decide. I decide for myself, but that's not what I'm doing here. So everyone has to decide for themselves what thing they call Bitcoin and what is the real Bitcoin. That's really a market decision. So the market is already speaking, and it's trading future SegWit2x coins against traditional Bitcoin coins. At the moment, SegWit2x coins are trading at about 1/3 or 0.3 of the value of traditional Bitcoin in the futures market. That, I think, is too early to draw any conclusions from. But if you're interested in how that will evolve, we have a pricing mechanism. That price discovery mechanism is telling us what the market is signaling. It can be quite easily manipulated by big players, white whales as they're called, who can come in and dump currency from either side and make the market move because it's too small and illiquid. But it's some kind of price discovery. So if you want, pay attention to that. Could SegWit 2x fail or falter due to clumsy implementation? Of course it could, and so could Bitcoin and traditional Bitcoin, and so could Bitcoin Cash, and so could every technology can fail or falter due to clumsy implementation. Part of the discussion here is about the quality and motivations of different groups of developers. And again, I'm not going to get into that. Daniel asks, regarding SegWit 2x, how was transaction malleability removed? Can it be considered an attack on the network? Daniel, the first part of the New York Agreement activated SegWit. SegWit is, among other things, a solution to third-party transaction malleability. So if you use a SegWit transaction, then the inputs that are protected from SegWit are the inputs that are signed with SegWit are protected from third-party transaction malleability. So more people using SegWit means less possibility for transaction malleability. It's not completely removed. If you use a transaction without SegWit, it's still malleable by a third party. I'm not going to answer, can it be considered an attack to the network? Anybody can consider anything an attack to the network. That, again, is a subjective argument. Max asks, would you consider a hard fork as some kind of an inflationary event or new money printing? Yes, in all of the alternative blockchains, including the ones forked off Bitcoin directly, every blockchain that introduces liquidity and new money into the market is an inflationary event. It doesn't inflate Bitcoin, but it does inflate the overall cryptocurrency market. Max also asked, could additional hard forks have negative effects on Bitcoin itself? It depends how they play out, I think. I think if hard forks happen and the end result is that Bitcoin proceeds with a majority on one side of the fork, I don't care which side at this point, that's a subjective judgment. But let's say one side of the fork wins overwhelmingly, then repeated exposure to that simply demonstrate that it's difficult to damage Bitcoin by creating dissent and hard forking the community, and then hard forking the network, and then hard forking the blockchain. So if you keep trying the same attack and it doesn't succeed, that strengthens the underlying system. It proves that it doesn't work. Now, this could be true even if a hard fork is executed as successfully as saying, okay, the hard fork happened and the new chain that was just hard forked gets 100% or 99% of all of the economic activity and users and wallets and exchange and merchants and miners. If everybody follows that, oh, that's a successful hard fork. So we'll see how it damages Bitcoin itself. My expectation, based on my experience so far, is that every time I have worried about the resilience of Bitcoin, I have been surprised by the resilience of Bitcoin. Vincente asks, if there's hard fork, how can I make sure that I'm the only one in control of both the new and the old coins? Which wallet should I use? Vincente, the answer is really simple. If you control the private keys, and the important thing here is to control the private keys in such a way that you don't have to really pick a specific wallet. You can switch wallets quite easily. Then you're good. So it's not which wallet should you use. It's have control of the private keys so you can change wallets anytime you want. So if your wallet isn't implementing SegWit or SegWit 2x or Bitcoin Cash, and you want to control your money through a different wallet that does give you the ability to control Bitcoin Cash or SegWit 2x or traditional Bitcoin or whatever, then if you have, for example, a mnemonic phrase or a private key where all your Bitcoin are held, then you can use that mnemonic phrase or private key to reboot a new wallet that supports the currency you want. I'll give you an example. I wanted to look at my Bitcoin Cash. So the wallet I use doesn't support Bitcoin Cash. So what I can do is instead use another wallet that does support Bitcoin Cash, connect my hardware wallet to it, and have it discover all the Bitcoin Cash that is stored on those private keys. So by having control over my keys through a hardware wallet or a mnemonic phrase or a private key itself, a paper wallet, something like that, I can choose which application, which user interface, which wallet I should use in order to access different types of currencies that are controlled by the same keys. Carlos asks, if someone propagates at the exact same time 2 double spending transactions, is it possible to find both in the mempool, or will nodes only accept one of them? Nodes will only accept one of them, as far as I know. I need to check on this, but from what I understand, one of the challenges, and this has been a debate in Bitcoin, I'm not sure which way it was resolved, but some people proposed propagating double spends, so that if you are a merchant and you see a transaction and then you see another transaction that double spends the same inputs, you know something bad is happening, and you can maybe decline to give the nice gentleman or lady the flat plasma TV they just paid for with Bitcoin. Other people believe that it's better to not propagate double spend transactions and to reject them based on the validation rules at each node, which is the status quo. I believe today transactions are not propagated. If one has made it into the mempool, it precludes the propagation of another. I may be wrong. They may have changed that. Christian asks, what is the threshold at which solo mining exceeds pool mining? Really, it doesn't make a difference. Solo mining and pool mining are really a matter of whether you spread your earnings over a long period of time or concentrate them in a single win. So the difference between solo mining and pool mining is if you do solo mining, you lose until you win big. If you do pool mining, you're going to gain a bit every day, but perhaps not as much as if you did solo mining. So that's really a matter of your operating model and not of how much hash rate you have. At the moment, I would guess that pretty much anybody who is mining with a pool. I don't think there are any solo miners out there, and if there are, they're insignificant. Let's see. Ashish asks, how are transaction fees and rewards credited to miners who mine the confirmed block? That's a great question. It comes up a lot, Ashish, and it's a really tricky answer. But the simple answer goes like this. I'm a miner. I construct the next block. It doesn't mean that that block will be included in the blockchain because I haven't yet mined the proof of work for it, but I construct it. I put whatever transactions I want into it. When I construct my block, I put a transaction in it that says, pay Andreas's address, 12.5 Bitcoin plus fees. I make that the first transaction, the Coinbase. In my block, the Coinbase transaction says, pay Andreas 12.5 Bitcoin plus fees. Who wrote that transaction? I did. I wrote it and I put it in there. Is that transaction real? Not yet. But if I then run my mining equipment and I find a proof of work solution and I am able to propagate that block and everybody accepts it as a valid block and they use it to extend their blockchain and it becomes part of the blockchain. 100 blocks later, I can then write a new transaction that spends that transaction I wrote to myself, and that Bitcoin is mine. So as soon as the block is validated, and as long as it doesn't get orphaned or reorganized out of the main chain, it becomes part of history. Everybody recognizes by incorporating that block my right to cash in that first transaction That is the fees and rewards. So miners write their own check to themselves, and they put it in a block that is not valid until they mine it successfully and propagate it. Once everyone accepts that that block is valid, that also makes the transaction in it that paid the miner valid, and as a result, the miner has successfully paid themselves the reward. The miner can write any reward they want in there, but it won't be considered valid if it exceeds the prescribed reward. So I could write, give me 50 Bitcoin, and everybody's going to reject that transaction because it exceeds the reward at this time, which will then make my block invalid, which means I never cash that check. So it's pointless. But if I write 12.5 plus the sum of the fees and it's the correct amount, it will be a valid transaction. People will see that I didn't exceed my Coinbase reward. I didn't exceed the fees that are in the block. And if it's a properly structured valid transaction and I mine the block, I can get to cash that in. I can actually, as a miner, write less reward. This has happened a few times. It's an interesting little quirk of the protocol. I can give myself 10 Bitcoin reward, and everybody's going to validate that and say, is 10 less than 12.5, which is the current reward rate? Yes. Fine. That means less Bitcoin gets mined this round. Doesn't happen very often, but it has happened. And I think that's most of the questions we have from the forums. Everybody, what do you have as follow-up questions? I'm looking at the forums right now, and there is a raging debate about which coin is the real coin and which one is the fake altcoin, which is interesting. Jesse asks, do you need to have your Bitcoin in a wallet versus an exchange to capitalize on airdrops or hard forks? Yes. If you want, you can depend on the exchange. Maybe they're going to give you the money created in a fork. Maybe they won't. Maybe they'll cash it out, sell it, and give it to you in traditional Bitcoin, and maybe they won't. It's not up to you. And here's why it's not up to you. It's not your money. And how do you know if it's your money? Your keys, your Bitcoin. Not your keys, not your Bitcoin. If you have an exchange holding you money, you've given them a loan, and they're under no obligation to return that or any proceeds from that loan created through a fork. If you want to control your own money, you must control your keys. Doesn't matter what wallet you put it in, as long as you control the mnemonic phrase, you can generate the private keys. You can do that in any wallet. All right, any more questions in the forum, or shall we wrap it up? Is everybody happy with everything we've discussed so far? Tracy has a question about mempools, how to read them. Great question, Tracy. Mempools. Some people say the Bitcoin mempool, such as the mempool is full. And one of the interesting things to understand about Bitcoin is there is no the mempool. The reason for that is because the mempool only exists in each individual fully validating node, meaning nodes have a mempool. And it's not the same as everybody else's mempool. It might be, but it's not necessarily the same, because a node may encounter transactions in a different sequence than other nodes. It may have a different threshold to decide whether it will include a transaction in its mempool, perhaps a fee threshold. It may have a bigger mempool or a smaller mempool. It may have an eviction strategy from the mempool that evicts transactions earlier because it runs out of space, or not. And it may have a bigger mempool or a smaller mempool with different transactions. So there are mempools. The mempools are everywhere. Miners have mempools, and they use those in order to construct new blocks. My node has a mempool, and it shows me which transactions are, as far as my node concerned, not yet confirmed. Everybody keeps track of their own mempool and propagates it to help other people keep track of the mempool, but there is no the mempool. So how do you read your mempool? You can do that by by running a command, for example, on Bitcoin Core or another fully validating node. Let's see. I'm just going to try and find. I can't remember what the command is. I don't have it right now, but there's a command within Bitcoin Core that allows you to see the mempool. It might be something like get mempool info. SP asks, do you think Bitcoin will move from proof of work to proof of stake in the future? Honestly, no. I think that Bitcoin will move from just proof of work to potentially having a hybrid algorithm or different algorithms for different layers. So you might have proof of work for layer 1, which is the blockchain, and proof of stake for layer 2 technologies like Lightning Network, which effectively is a proof of stake. Marissa asks, can transactions hit more than one node in the same order in practice? Yes, if the rate of transactions is pretty small, then mempools are going to get the same transactions in the same order. If there are a lot of transactions coming in and they're coming in from different directions in the network, then it's expected that you will see some nodes will see one transaction first, some will see another transaction first, and therefore the sequence will not be the same. What is the text on my T-shirt? Let there be dark. It's a comment about dark markets. Dennis asks, do I recommend that those in the community download the full node to support the system? Dennis, I recommend that you run a full node. And the reason I recommend you run a full node is that you can learn how it works and you can gain from the experience. You can do so while pruning. You can do so while pruning the blockchain so that you only store, say, 500 meg, a gig, 2 gig, 5 gig, whatever your hard drive can fit. And you can also limit the amount of bandwidth you use by setting various other restrictions. Some of those details are in Mastering Bitcoin 2nd edition. You can see how to tune a node in order to reduce its memory and disk footprint, but still fully validate every block and every transaction from the Genesis block until today. It will teach you something. It will also give you an authoritative way to validate your own transactions or transactions that you care about. And the more nodes that are running, the harder it is to partition or censor or disrupt the network by shutting down nodes, putting up firewalls, and things like that. You can also experiment with running a node on Tor as a Tor hidden service, which again can serve a lot of other clients and protect their anonymity. All of these are good things to do, and it gives you a stake in the network. Let's see, just one more questions or. Very good. N. Morris says, do you have recommended reading on cryptography, cryptology, not just OpenSSL how-to, but algorithms? I'm trying to remember, and I may have to look this up, but there is a very famous cryptography open course, like a MOOC, like this. I believe Stanford does it. I'm not sure. I think it's Stanford. It might be Berkeley. I'm not sure. One of the big universities has an absolutely famous course on cryptography. It should also be on Udemy. And that will give you a very good overview of cryptography in general. Algorithms, details, how it works, all of that. So have a look at that. And great. Thank you all for attending. Fantastic session as always. Great questions, more questions than I could answer in a specific session. This is session 5 of the Massive Open Online course for the University of Nicosia's master's degree in digital currency. This is the 8th time we're running the MOOC, busy as ever. Thank you all for the fantastic questions you asked in the forums over the past week that allowed us to put together this video. And also thank you for the live participation in the chat and the great follow-up questions. Really, really great stuff. Looking forward to seeing you at the very next session in about a week. Don't forget, study, ask questions early, discuss them amongst yourselves, and that will give us plenty of material to cover. Thank you so much for coming today, and see you soon. Bye.